Good morning, everyone. So we'll wait a few seconds, probably a minute or two, just to make sure that we have everyone joining on time. So I think we're good now. Attendees, so we have 75 people on the line. That's great. So again, if you were there yesterday, my name is Matthew. I'll be the one introducing all our speakers over the week. So we did 3 classes yesterday. We have 3 more classes today, and that's going to be 3 classes every day until Friday, end of the day. So today is going to be a little bit different than yesterday. We have 3, let's say, external presentation outside of Greatech. So this morning we have a streamlining connection design workflows between detailers and engineers. That's going to be presented by Wojciech and Vit from IDEA StatiCa. I'll let them introduce their company real quick. At 1:30 p.m. Eastern time, always, we're going to have Amy Stevenson from Graph USA. She will be presenting what they call Graph Accelerate. So it's a service to offer engineering and still detailing for some projects. So that's going to be really interesting. And at 3:30 p.m. this afternoon, Luke from the AISC, so the American Institute of Steel Construction, will do an hour presentation on what's new about the AISC, and probably cover a little bit of the NASCC content as well, considering the event was canceled. And guys, this is why we do this online this year. Normally our user group is live. We're following the NASCC show. So we have normally around, 40 to 50, 60 users, depending of the year. That said, doing it online like that is really good because way more people can attend those classes. So we're really happy about that. So I'll introduce Vit and Wojciech right away. So Vit, Wojciech, are you on the line? Hopefully you are.
Yes, we are.
Yeah.
Okay.
Hello, everyone.
So let me give who's gonna control the screen on your side.
I'm going to start, so I will take the presenter.
So that's Vit.
Yep.
Okay, awesome. So here you go. Floor is yours.
Great, Matthew. Thank you very much. Welcome, ladies and gentlemen. We are going to show you some really nice streamlining connection design workflows between detailers and engineers. Welcome on Advanced Steel Academy 2020 on behalf of Greatech, and we are from IDEA StatiCa from Czech Republic. Because of the COVID, only on the web pages, only online. So let's start. We have a really nice 1 hour in front of us. My name is Vít and I'm product engineer in IDEA StatiCa.
My name is Wojciech Chalupa. I'm a product development engineer in IDEA StatiCa, and I'd like to thank you all for having us today.
Great, let's continue. Why are connection a topic for us? Well, every really nice attraction or structure or hall, it's designed from small things, and these small structural parts are connected to each other. And we are proud that ProSlide company is one of our customers in the Canada and United States. ProSlide Technology Incorporated is a design and manufacturer of highest performing water slides and rides and water parks around the world. They have more than 4,250 installations around the world and 190 global employees. ProSlide is a global company, which is important for us, and we are proud of delivering system solution for connection design to them. And every fancy water slide must be supported by a steel structure, and the connections are key for the whole project. IDEA StatiCa Connection application was used to design and co-check of these steel connections. And for example, most loaded representatives from the whole structure were chosen and designed and co-checked. IDEA StatiCa Viewer is a cloud solution for designers and engineers, and it's provided for free. And in the next few minutes, we are going to use it and show it to you and talk about more about these features of this cloud application. And by the way, in the last 90 days, 12,647 connection types were shared in IDEA StatiCa Viewer. So it's quite a topic. And it's good to know more about it. One small word about us. We are IDEA StatiCa company based in Czech Republic. We are a family company, and we have development team with more than 20 years experience behind us. And thanks to the great tech, I'm glad that we can be here today together to show you some really nice BIM solutions.
So, just to let you know, I closed your webcam because some comment in the chat. The sound was not A1, so closing the webcam will probably improve it. Okay.
Okay. I hope it's better now. And well, let's focus on today's story. One of the possible scenarios in the construction industry is shown. A client has a need or pain, and the contractor is hired for delivering the solution. And the engineering consultancy is needed, of course. They have together one project and one goal. But in fact, they are two professions, the detailer and the engineer. Do they have different needs? Do they have different workflows? Yes, of course. But we need to make plus between them to make them cooperate effectively with effective connection design workflow on one goal, on one project. And we have the technology right now, nowadays. So let's use it, and we are going to show you, demonstrate you some demo. Together with my colleague Wojciech, we're gonna act a character play. I'm gonna be a detailer, and I'm gonna use advanced steel, and my engineer Wojta will use robot structural analysis, and together we are going to play. So I hope everything is set. Sit tight and enjoy. Let's start with the initial design. I, as a detailer, I have some demand from a client. The layout was sent to me, and because I want to use my standard solution, my pocket solution, I'm going to fine tune to use this solution. I'm going to send this layout to engineer as a resource for his job. From my years of experience, I know how to design simple collection, and I'm gonna use this knowledge. So I'm gonna do a design of standard connections, simple ones, and the complex one, that is a different story. I will demand this design on my engineer. I'm going to use Advanced Steel Viewer plugin because with this I can easily obtain the connection files, project files, and send them to engineer, to consultancy. Let's start with the demo in a real time. Okay. Let's say I have this layout as a starting point. Usually we have these standard solutions for structures in our pockets, and I'm going to use it to satisfy the needs of the customer. This solution is already prepared in my advanced steel structural model, and I'm going to send these layouts to my body engineer. Email, and I'm going to attach the plans elevation. This will be the start of his job. I'm going to start my part of the job. So I'm going to pick a representative of each typical joint. Let's say I'm going to design this platform joint in the first floor. I'm going to design this platform joint at the roof with shear plates. I'm going to design this X-bracing joints at the roof. And well, the masterpiece of my design experience and design job is this X-bracing joint in the wall and the first floor. And finally, I'm gonna ask engineer to help with the design and the co-check of those two complex connections, the frame joints at the end part of the frame and in the middle section. So to start, I'm going to use IDEA StatiCa Viewer plugin, and this viewer I can download easily and for free from IDEA StatiCa web pages. So here is IDEA StatiCa homepage and downloads. Here is Viewer plugin for Autodesk Advanced Steel. With this plugin installed, I have here a new tab, IDEA StatiCa and IDEA StatiCa Viewer. I can export to several codes, but for me, it's important the AISC. So choosing the command, oh, sorry, I need to change the model view scheme. And by choosing a command, I started the export. And it's going to be in 3 steps. First step, I have to select the node, the connection point. Okay. It will be in this midpoint of the beam. And second step, choose all my members. And the third step, all other things like bolts, plates, and other connection entities, welds also. And in a few seconds, IDEA StatiCa Viewer, which is cloud solution in your web browser, is launched with imported connection. I can check out the item properties like bolts properties, plates properties, etc. Here in design. Okay. One of really important feature, I can download IDEA StatiCa project files. Great, it's here in my download directory. Right? So let's do another one, connection. The second connection will be the roof shear plates. So again, I need to choose the connection point, then the first beam and both roof beams and all other entities. It's going to and from the server, and in a few seconds I have the connection imported to my viewer. And again, just download the file. Nice. And we can proceed to another one. That's the second one. This will be the bracing, roof bracing. Okay. Connection point, first beam, and the bracing. Every time I just confirm with the space bar or right mouse button. Usually you do the same thing when you are dealing with the commands in Advanced Steel. That's nothing unusual. So download the IDEA StatiCa project file. Great. Next one. Here it is. My masterpiece. I'm really proud of this one. Okay. Main beam, first floor beam, and the bracing. Okay. Nice. With more items, it could take more time. Maybe you just now experience the longer import time, but check it out. I think it's worth it. It looks complex, but in fact, it's a simple platform joint with two gusset plates on top and at the bottom, connected only by cleats and by plates. Great, so download it. Again, I have another connection file, and let's jump back into Autodesk Advanced Steel and two more. With these, I want to help from engineer. So I'm going to export them only as a members because I want to inform him about the cross sections and about the geometry. So first step is without a selection. And that's it. Only members and the geometry. Download it. Great. And the last one, the sixth connection. Okay. Here it is. Connection point and 4 beams. Third step is without selection. Okay. Great. So download it, and I have the full package. And right now, I'm going to send it to my structural engineer Wojciech. Project files and layouts with marked position of the joint connections. Okay. Okay, and I'm going to insert them. This is my downloaded project files, all of them 6 IDEA connection projects. Great. And together with this, I'm going to send the planned elevations with marked positions of the connections, so engineer knows where it is. Okay, send it to engineer. And right now it's time to go back to the presentation. And it's time to switch the roles.
Okay, so I will now make myself the presenter. I will share with you my screen, and I will now start where Vid has left off. I have received the files from him and can start my part of the project now. After reviewing the documents from Vid, I was able to create FEA model using the robot structural analysis. Then I will use the CodeCheck Manager, which is an IDEA StatiCa plugin, to export representative connections and co-check the simple connections sent in by the detailer. I will also use it to design the complex ones, which he has asked me to do for him. In the end, I will send the connection files for him to review, also some sketches, and we can go on. So this is the file that I've received. Based on this, I have created an FEA model in Robot. This model has a couple of load cases. It has, for simplicity's sake, one ULS combination according to the AISC. I have already checked the cross sections of the members and will now design the connections, which is the name of the game in IDEA StatiCa. For this, I will be using our plugin called the CodeCheck Manager. This plugin allows me to export model nodes. I will just select the correct design code. It allows me to export model nodes with all their data, such as cross-sections, loads, materials, etc. So I will start by selecting the couple of simple connections and import them into our CodeCheck Manager. You can see them highlighted when I select them after a successful import. So this is the roof connection. This one is the one on the floor. I will continue with a representative of the bracing connection. You can import them one by one or in bulk. Now we have another bracing connection with its masterpiece in the wall. And then he has asked me to design those two. So I will also select them so I have them ready. Okay. Now we have to go through them and check if the loads that we want to import are indeed imported. So when I click the definition of loads button, I can see all the load groups that are defined in the robot FEA model. On the next page, I can see all the load cases and combinations. And on the last page, I will define which of these I want to use for the design. So again, for simplicity's sake, we will use just the one linear ULS combination. When I click the Finish button, we can open the app. This is our desktop connection app. This is not a free solution, but it's well worth the money. When I open it, we can see what we have managed to import. We can see the column, all the beams, and all the loads. Now, what I can do is make use of this data, since I have this data for all the 6 connections. And I can have a look at what Vid has sent me. I have it downloaded in here, detailer data, and I can open these projects, make use of Vite's work. They are already modeled, so we just need the loads from my model. For this, we can merge them and make use of our connection import option. I will quickly check which node I have selected. I think it was the node. Let me turn off the shapes, number 71. So now when I import the loads from the connection number 71, we should see the loads appear, and indeed they do. And now I can calculate this joint. One thing that I need to do is specify the shear force position, because this is a hinged connection and the shear force should be acting in the bolts. That's why I selected the position of the shear force. Now I can calculate this joint. What you will see are the results. We use something that we call the traffic light system, where the green items are fine, the orange items are near the limit of their capacity, and the red items do not work. They fail the check, and we have to redesign them. I'm sorry, I will now have to try to cancel the calculation and run it again. I'm having some connectivity issues, so I hope everyone can see and hear me just fine. Now we'll start the calculation again.
Yeah, we can hear you pretty
Yeah,
easy.
that's okay. These things are fine now. Okay. So we can see, as I said, the traffic light model, the green parts are okay. The gray parts, the utilization not quite there. So we could perhaps save some material. I suggest we try to design this connection as a single-sided cleat. So I will remove the bolts, remove the cleat, and redefine this bolt group. There will be only 2 connected members now. One of those will be the stiffening member, and one of those will be the web of the cleat. Okay, I'm clearly having some issues. So excuse me, I will close this one, and I will try to show you on another.
In the meantime, Lynn, would you like to move forward with the poll?
Sure, of course. Here we go.
Taking a little break.
Here's a little poll here. Do you currently have engineers on staff doing engineering calculations for steel connections? Easy enough question. Okay, so the answers are still coming in. Okay, seems to have stabilized. So I will share the results. So yes, we have quite a bit. 79% of the people attending today are doing it in-house. Okay, so hide. There we go. So another quick question. Do you currently use Advanced Steel Connection in your company? And if so, how long have you been using it? Oh, interesting. So it's pretty much half and half, actually. So, okay, thank you very much for your answers.
Okay, so I will now continue with designing VIT's connections. Here we have the connection in the roof. It is also satisfactory. The check is fine. When I open the bracing, which according to the layouts was number 3, I can also import the loads from the robot model. So let me just check which node that was, 214. Okay, the loads are here. Let's calculate it. And again, I can see the connection is satisfactory. We can also see more detailed results, such as stresses on the plates, etc. I will get back to that when designing the more complex connections. So let's go ahead and finish all the connections that VIT has sent me. The last one will be the X bracing in the wall. So that was connection number 104. Let's import the loads from this one. Okay, and run the calculation. And let's see if this one needs some modifications or not. Yeah, I can see that the plates are in green, the bolts are in orange. We can see their utilization is at 100% almost. So that for me is an acceptable design, but I could also recommend to add a row of bolts, for example. So as it is, I can say that this joint is okay as well. I will now close our app and go back to Robot, where I open the CodeCheck Manager. Since VIT hasn't designed the two connections, there is no use for me to merge them. I can start fresh. So those would be the connections 14 and 17. I'll just check. Yeah, this one is the 14 and this one is the 17. I need to define the connection number 17. The column is continuous. And I can start designing now. So when I open this project, the floor beams will be again hinged. So I will use the cleats on their webs. The girder, that's the beam number 12, will be rigidly connected to the column. So let me start the design. I will select the beams that I want to connect, and I select the way of how I want to connect them. I will use the same bolt grade as VIT did, and the same cleat cross section. you can see the operation is done. I'd like to use 3 bolts, so I will shorten the cleat, and I will also remove one of the bolt rows. Okay, I think I like this design, so I will use it also for the beam number 7. There we go. And we can move on and design the connection of the beam number 12. Let's add a cleat operation and specify that the web of the beam 12 should be connected to the web of the beam 7. We can add another cross-section. Here I have a group of cross-sections that I have favorite. We of course have the full connection and cross-section libraries. So from these I will select perhaps an unequal angle, add it to the project. I will define a gap between the beam and the column's web. I can also add bigger bolts. So let's do 3/4 of an inch. And now for the bolt rows and positions. So I will just quickly define these. Seems about right. Also the cleat is too long, so let's shorten it. There we go. And for the positions on the web, let's also use a 3-inch spacing. Okay. Now, for the connection of the flanges, we can also use a cleat operation, specify that we want to connect the flange of the beam, but this time we will use a T stub. So in the cross-section menu, I will add a T stub. Again, I have the wide flanged beams favorited, and I will pick one, define the height, and I still have to define the bolt positions. So I'd like them in 2-inch spacing and 3 inches in the other direction. As for the bolt rows, 3-inch spacing as well. And the connection looks quite all right now. Let's copy this one to the bottom of the beam as well. So I just need to specify the flange and change the side on which the cleat is applied. Okay, I should also change the positions of the forces before I run the calculation. And I'm using the factored design since in my model I have also used the LFRD. So let's run the calculation, see what happens. All right, I can see that the solver is slowly converging to a solution. But I can see that some of these elements are red. Indeed, their utilization is quite over their capacity. So I have probably forgotten about something. We should, since this is a rigid connection, we should probably add some stiffeners. So I'll go back to the drawing board and add a stiffener operation. I guess a 1/2 inch thickness would be all right. We will do 2 of them. We will their mutual distance can be defined. And I'll try to put them in the middle of the bolt groups. I guess this looks all right, we only need them on one side. So I'll use the stiffeners only on the back side of the beam. And I'll run the calculation again. Okay, everything is green. The results are fine. These results are based on the AISC code checks. We can have a quick look at the report, which I can export into PDF or other formats, and which contains all the data about the design. So I have the beams and the columns. I have the cross sections, the bolts and their material properties. I have the loads that I've used, the summary check, and then detailed check of all the plates, pictures of the traffic light system check, the strain check in the plates, and of course the equivalent stress on all the plates. There we have the checks for all the bolts and the bolt groups, their design data, resistance in tension and shear, and checks for all the welds. So I will export these and will be sending them over to Vite. So we can go ahead and design the second connection. That would be the column in the middle. Again, the floor beams will be hinged, the girders will be framed, will be fixed to the beam. For this design, I will make use of a user template, which any user can do. This template is for bolted flange plates. So when I click the Apply Template button, we should see, also have to define the bolt group. Let's use the 490. We should see the design is performed, and we have the plates bolted to the flanges of the rigidly connected beams. What I now have to do is, again, to connect the floor beams. So let's use the same connection as before. Define the length of the cleat, define the bolt positions, and use it for both of these beams. Check if we have the force positions correctly set up. And run the calculation. Okay, so this time it looks like that I have nailed the solution on the first try. I could enlarge the bolts if I felt like 97% utilization is too high for me. I can show you the report as well. This will basically be the same as in the previous case. So let's perhaps show the bill of material instead. That's something I haven't shown yet. So the report is the same as before. And now for the bill of material. In the bill of material, there are all the plates with their material, their thicknesses, all the bolts, count of the bolts, and detailed drawings of all the plates used in the project. So that's something that my detailer can use to better orient himself when he receives my recommendations and my designs. Another tool that I can use to make his life easier is the create sketch or create a section function, which I can use on any plate in the model. When I click on a plate, the scene changes. It almost resembles a drawing now. And I can define a sketch for my engineer so he can perhaps use that. I can export that. It is also in the bill of material. So if he likes, he can check this for the weld size, for example, or the plate size, etc. I can also do one more for the fin plates, for example. So let's create another section, and I have to tweak this one a little so that the fin plate is visible. I can move this section window around in the model, and let's see. Yeah, I think that this is fine with the dimensions and everything. So Vit will receive this one from me as well. So now what I have are two connection designs, bills of material, and also a recommendation about the floor beam where a single cleat can perhaps be used, not both sides connected using cleats. So I will create a new email. I will send this data over to Vit. Those would be the bills of material. Those would be the IDEA files, so he can open them in the viewer and review my design. And I can say cleat connection only, single-sided can be used. That's the connection 71. Okay, that's it from me for this demo. And I will hand it over to Vit to see what he can come up with.
Hello again. Let's proceed with my design part. I obtained from Wojciech, the engineer, bills of material of my connections and project items which I can explore in the cloud viewer. And those two things will help me to understand how to design it in a structural model in advanced steel. Then I'm going to do those changes according to the engineer recommendations. And then I'm going to change some section for X-bracing because we need to do some change from our structural and construction point of view. So let's do that. From Wojciech, the engineer, I obtained these files, bill of material for two connections and these project items. So let's open the bill of material, and I'm going to study this section because it will help me to design it properly. I can see the dimensions, labels for the plates with dimensions and thicknesses. I can see the throat thickness or the leg size in the AISC and the type of the weld, and also the bolts. If I will go down, I will see the same thing for the beams and the webs, which is great. I can understand now the design which engineer did. and I can see the detailed dimensioned plates, each of them, which is great because now I have almost anything that I need. Right now, I need to see the whole picture, and I can see the whole picture of the connection in IDEA StatiCa Viewer. So again, you can go to home page, to cloud, and here is IDEA StatiCa Viewer free solution from for designers. I'm going to open connection file, and this will give me the overall view, the 3D view of the connection, and I can check where are those plates, how they are placed. The welds are made, the cuts are here. I can see even the thicknesses of the welds here, which is great, and the electrode info. That's all that I need as a designer for my input and for my review of my structural model. Great. And moreover, I can download the 3D DVG file, which will help me if I need some more information. So right now, I have enough information to do my review of the structural model. With this info, I'm going to design this connection. It's already designed, but I did it in my past time, okay? During the demo of engineer. And the engineer also recommended me to save some material with this platform connection. Okay, I will do only one-sided cleat. Let's say I can delete this one and this bolt group, and this will save some material and some structural time, erection time, and also save money. And the last thing, let's say as a contractor, we have in our warehouse, in our storage, a lot of steel material, and we have numerous let's say bars with L-shaped cross-section. So we are going to use them because we need to use them and save the money. So I'm going to change this L angle bracing in whole bracing for the whole model to smaller one, let's say this 4x4x1/4. Okay, is it that's it? And practically I finished my my model, my structural model, and I can ask engineer for check if the bracings are okay with the changed cross section, and then I can do my shop drawings. So right now I'm going back to our presentation, and I'm going to offer the presenter for Wojciech, the engineer, again.
Okay, thank you, Vít. I am taking the presenter now and sharing my screen. So the detailer has requested that I change the bracing cross-section to make use of the material that's already available. I will change the cross-section in the robot structural analysis. I will recalculate the model and then synchronize, calculate, and code check all of the connections. Okay, so this is my model. I will now select the cross-sections that are affected. Those would be the bracing ones, change their cross-sections according to detailer's request. This will, of course, prompt the structure to be recalculated. So let's go ahead and do that. And we now have the new results. Let's say the cross-sectional check is fine. The member satisfies even with the lower thickness of the arm. So when I launch the IDEA StatiCa, we need to recalculate the connections. Of course, we need to recalculate the one where the cross-section has changed, but we also need to recalculate the others because the internal forces were probably affected by this change. So what we need to do is to synchronize all the items. When I click this button, you can see in the background what's going on. The algorithm is going through all the connections and is looking for changes in materials, in cross sections, and loading, of course. So when the sync is done, I can have a look at the bracing connections, make sure that the angle profiles are indeed switched. So now the sync is complete. And let's open this connection. To review and also recalculate. And from what I can see, the angle is now a 1/4 inch. Angle's arm is now a 1/4 inch thick. So let's run the calculation if it's not too thin now for the bolts and the forces. And it looks like it is not, so I can approve the detailer's request. And I can also calculate all of the other joints. I can calculate all of them. I can calculate one by one. And the point is that I don't have to go back to the app. I will just click the calculate all button and all of my imported connections will recalculate based on the new model results. And I can see the results that are summarized right by these connections. So let's perhaps do one more. And now my job is basically over, provided that all of these satisfy. I can send these IDEA files over to Veed for a review. I will also attach all the reports that are with these connections. And let's do that first. Let's create a new email, attach all of these connection files. This is the design for fabrication. Send it over. And this basically concludes my part of the job. Having done all the checks necessary, I will now send these over to the detailer who can finish his shop drawings according to my designs and recommendations. With both sides now having done their part, the project is now ready to be built and our common goal has been accomplished. We shared a lot of data, we were able to react to changes, and we also hinted on some workflows that you can take advantage of when using these products with the IDEA StatiCa links. This was our assumed workflow today. There certainly are other arrangements possible, but the effective communication between the detailer and the engineer is always a key to success. So what should be the takeaway for you today? What did we hopefully manage to show and communicate to you? The next time you come across complex connections like these, or indeed the ones that we've had in our sample project today, or even the simplest of connections, and you get asked these questions. Can they be built? Are they safe? Can you prove that through code checks and calculation reports? How long will all this take? You can always remember our today's demo. The tools, as we said in the beginning, are there for you already. If you are the detailer, you can export connections to IDEA StatiCa and read other IDEA StatiCa project files in our viewer for free. If you are the engineer, you can design connections using the CodeCheck Manager, the IDEA StatiCa Connection. You can use that in your FEA software of choice, and you can share those designs with anyone using the viewer. So I'd like to thank you for your attention now, and it would be a great time for questions. If you have any, we will try to answer them to the best of our abilities.
I have one question from the audience, or there will be more, but one I promised that we are going to answer it online in the webinar. And I think it will be suitable for you, Vojta, as an engineer. One of our attendee, Eric, is asking, does the design model has to be done in robot? Can the connections be checked in IDEA StatiCa if the design was done in another software other than robot structural analysis?
I have a good news for you, because yes, it can be done. You can open IDEA StatiCa, model the connection from scratch. You can import the loads in any way that we provide through the links that I've shown, also through an Excel file by simply copying and pasting them or simply writing them in. We have BIM links with most of the software that is used, so check our website for the availability of the BIM link that you would like to use.
Great, thank you for the answer. Basically, that is it. We can quickly, if you have some more questions, we still have a time. You can type it in and we will answer it. Or you can send us the questions or to our colleagues Matthew or Lina to Greytech, and we are, because we are communicating with each other, so it's okay if you have contact to them.
Yeah, sound like we answered almost everything. And yes, it's going to be available as a recording. I got that question just now. So all session of the Advanced Steel Academy, you'll receive the recording a few hours after. So I'll take back the screen just to a friendly reminder everyone that Greytech created Advanced Steel back in the days. We sold the software to Autodesk, so we're still around. We're still offering, of course, licensing, but on top of it, for Advanced Steel, especially basic advanced training, some consulting, drawings, customization are always one of the most popular topics that we have. We offer daily support as well through your Autodesk license. So if you have licenses with someone else, you can always renew with us, and you get our support included. We have few add-ons available. We showed them yesterday, Power Pack for Advanced Steel, BIM Designers, Certain Rating, and of course, what we saw this morning, you can buy in the US and in Canada, the IDEA StatiCa software that we rebranded for Greatech to Advanced Design Connection. So we have, we do local support as well, because sometimes dealing with Europe is not the easiest, easiest scenario. So we do direct support of this specific product. And stay with us today at 1:30. So in a 90 minutes, we'll have Amy from Graph doing our presentation. So hope that everyone enjoyed, and talk to you later. And thank you guys for your time. Really appreciate it.
Thank you for joining, and thank you very much to our speakers.
Thank you to watching us. Thank you to spending time with us. It was a pleasure for us. And I hope that next year we are going to see you personally. So fingers crossed, and we are going to meet personally next time. See ya.
Okay.
Yeah.
Thank you very much.
Thank you very much, everybody.
Bye-bye.
Bye.
Bye.